Okay, so in doing that, we know we've got a right triangle. Anytime I'm trying to find a missing side and it's a right triangle, then it is, we can use Pythagorean theorem. Okay, so to find the apothem ST, A is equal to the square root of 8.3 squared, because that was the length of the hypotenuse, minus 2.15 squared. That is going to be the length of that one side. Okay, so we've done, we're squaring each of those. Now we've got to find the square root of those, and that's going to be approximately 8 feet. So now we found the perimeter. We have found the apothem. Now we've got to use the perimeter and apothem to plug into that area of a regular polygon formula where A is equal to 1/2 times A times P. So we have 1/2 times the apothem, which is 8, times 51.6, which is P. And we can see that the total area of our figure is 206.4 square feet. Remember, when I'm finding area, I report my measurements as whatever squared, or square feet, inches, whatever it is. Okay, so area, I'm always going to have an answer that involves squaring something. Okay, so in that problem, I couldn't just find, I needed to find the perimeter. I had to find a missing side, which was the apothem, which meant I had to use Pythagorean theorem. Then I had to use the area of a regular polygon equation. Okay, so there's a good bit of work involved in just that one example. So again, this is going to be something you'll need to look back to with the homework. And speaking of, when we turn the page, we're at guided practice. So on page 672, number 1 says identify the center of polygon ABCDE. So what point is at my center? J. What is the radius of the polygon? When I look at my radius, what is my radius?
JE.
Not, well, JE, but it's not marked. Is which one can I see a measure? So that is an example of the radius, but what other example of radius gives us a number? That's going to be the apothem. JK is the apothem because see, it stops at the edge of my figure. Look at JC. Notice that JC goes from the center to a vertex on my figure. So it actually is reaching the edge of the circle. So I can see that the radius is going to be 5. Okay, so look at that and notice that the radius is different from the apothem. JC is a radius. JK is the apothem. That is why they are different numbers. Central angle of the polygon. So think about, what is a central angle? Okay, CJE. So we could have CJE, we could have BJE. Okay, so central angles are going to be ones that go to the center, CJB. Okay.
Can KJE be one?
K what?
KJE.
Is K on the circle? No, so it could not be because it's not on the circle. All righty, let's go ahead and look at number 4. Identify a segment whose length is the apothem. JK, good. All right, so number 5 says, in a regular polygon, how do you find the measure of each central angle? How do you find the measure of each central angle? Now remember, it says it's a regular polygon. So that means that all of my side lengths are the same, all of my angle measures are the same. So what do we know the whole thing all the way around would be? 360. So I'm going to start with 360, and then I would just divide by the number of sides. So 360 divided by, if it's a quadrilateral, divided by 4, we're at 90. If it's a pentagon, a hexagon, whatever it is, you just take 360 and divide by the number of sides. Okay.
So if there's 5 sides, we divide by 5?
Yes, and that's if you're finding the measure of each central angle. Okay, so if you're looking at the central angle, where it's an angle that is from one edge of my circle to the center, back to another edge. Okay.
72.
All righty. So number 6 says, what is the area of an equilateral triangle with 3-inch sides? Okay, so let's think about this. What was my formula? Flip back. What was my formula for the area of an equilateral triangle?
Would it be
A equals what?
1/4.
A equals 1/4, the square root of 3, s squared. So the question is asking us, okay, what would it be if each side is 3 inches? Okay, so I know that S is equal to 3. So I'm going to have area is equal to 1/4 times the square root of 3 times 3 squared. What is 3 squared?
no?
Okay, so in this, notice this is going to be the same as area equals 1 times the square root of 3, which is just going to be the square root of 3 times 9 over 4. Everybody good with that so far? Okay, so when I look at this, I can either leave it as just 9 times the square root of 3 over 4, or I can use a decimal. So let's look at, see, what is the square root of 3?
It is 1.43.
Okay, now multiply that times 9.
15.5.
Now divide by 4.
3.89.
Okay, so it's approximately 3.8971, so we'll say 3.9. Okay, and remember this is inches squared. Okay, so that's one of the things that you can do.
So can we leave it at 9?
You can leave it as a simplified radical. So remember, a simplified radical means that this has been simplified, my radical is simplified, and if there's anything that can cancel with my whole number, so like 9 and 4, if those could be simplified, if I was able to divide, like if this was an 8 and this was a 4, well, 8 divided by 4 is 2. So I could simplify that. So as long as this is a simplified radical answer, that is fine.
So now it was
Or you can
8,
plug it into your
it was
calculator.
8, so we divide it, it'd be 2 times square root of 3, right?
Yeah, so if you can simplify further in your radical answer, do that, or you can plug it all in and use a decimal. Okay. Alrighty. Let's look at number 7. What is the measure of each central angle? What kind of shape do I have here? Octagon. How did we say we find central angles?
Oh, multiply, no, multiply, divide 360.
By the number of sides. So 360 divided by 8 is going to be what?
45.
45. So each angle measure is going to be 45 degrees. Okay. Number 8 says find the apothem, radius, and area of the stop sign. Okay. So number 8, apothem, radius, and area. So I know I have an octagon, which has 8 sides. Okay. Let's look at the information. It says the stop sign shown is a regular octagon. Its perimeter is about 80 inches. So we know that P is equal to 80. And its height is about 24 inches. So H is equal to 24. And we need to find the apothem, the radius, and the area. Okay. So we know that the perimeter is 80. So what does that mean the measure of each side is? 10. So each side, S is equal to 10. Okay, we know that. What do we know the height is?
24.
Okay, so if my height is 24, then what is my apothem going to be? 12. Why? Okay, so remember when we're talking about our shapes, and if I'm talking about my height, that's from top to bottom. That is not in the vertex, okay? Because remember, if we were inside our circle and we went vertex to vertex, that's going to be our diameter. But if I go from side to side and we said that was 24, then our apothem will be half of that. So our apothem is going to be 12. Okay. So now the radius. So let's think about our radius. If each side is 10, how can I find my radius? Huh? Pythagorean theorem. So what do we know? We know our apothem is 12. Okay, so we know that this measure is 12. If I know my entire side right here is 10, what does that mean this little segment here is? 5. So now I know this is 12, this is 5, and I've got to find my radius. So when I make that right triangle, what side of my triangle is that? That's the hypotenuse, right? So this is what's going to be my radius, so that's going to be my hypotenuse. So to find that, I'm going to have, we'll call it the radius. So radius squared is equal to 12 squared plus 5 squared. So radius squared is equal to, what's 12 squared? 144. What's 5 squared? 25. So r squared is equal to 169. So what is r equal to? 13? Okay, so now we found that our radius is 13. Okay, now we need to find the area. Remember our area formula. A is equal to 1/2 AP. So 1/2 my apothem. What do we say the apothem was? 12. Our perimeter was 80. What is half of 12? 6. What is 6 times 80? What's 6 times 8? 48. So 6 times 80 is going to be, okay, 480. And what is our measure of units? Inches squared. So 480 inches squared. So in this problem, they gave us the perimeter. So, but we had to figure out what a side was. So in some of our problems, they may give us a side and we have to calculate perimeter. All right. They told us the height, which helped us find the apothem. In the previous examples, they gave us a diameter and we were able to find the radius. So in this situation, though, we had to find the radius. They gave us information to quickly identify the apothem. But then once I've gotten my perimeter, my apothem, and then half of my side, that's when I was able to plug in, that was when I was able to plug in to find my area, and then I had to use all of that in my problem, okay? So go step by step, think through the process, look back, especially at example 4, okay? Examples 3 and 4 are gonna help you with those. All right, so our homework,
I have a question.
yes.
The apothem, radius, and area, are the measurements all inches squared?
In this particular problem, they said that no. So remember, area is going to be the only 1 inches square.
Okay.
Okay, so when I find area, that's always represented as square units.
Okay.
So the others are just going to be just a single length.
Oh, okay.
Okay. All righty. So our homework in this section, 11-2 is page 672 to 673. Numbers 9 through 25 odds and 30 through 32 all.
So 31.
So that'll be 30, 31, and 32.
I love odd.
And then mixed review is page 675, 54 through 63 odds. Okay, so look back at your examples. Think through what you're doing. Use the information they've given you. Figure out what you need to find. And go from there. Look back at your examples. No.
Funny joke.
All right, 11-3, perimeters and areas of similar figures. So we've talked about perimeter already, and we talked about how perimeter is the distance around a figure. And like I said, when I think about perimeter and area, you know, sometimes it can be easy to get them mixed up or figure out. Perimeter, I think about a fence, and area would be like laying sod. Okay, so area would be putting grass in between the edges of the fence. All right, so that's the difference between perimeter and area. And so bullet point 1, for any polygon, the perimeter of the polygon is the sum of the lengths of its sides. So bullet point 1 on your notes. Note packet. We got a note packet, Alec? Okay, good.
I think I might have given you that back in my slide.
With chapter 11, or was that, I think you gave me chapter 10.
I know, but I had them in the same place.
Wait, what? Huh?
Chapter 11 notes, bullet point 1. Oh, yeah, you sure did.
Oh, okay. I was like, I don't know.
Yep.
Okay.
Okay, the sum, which just means I add them all together, okay?
Talk about it. I didn't think about this,
And that's what it says in the beginning, and it says in the area on page 677 at the top, and the area of the polygon is the number of square units contained in its interior. So bullet point 2, for any polygon, the area of the polygon is the number of square units contained in its interior. So it says in lesson 8.3, you learned that if two polygons are similar, then the ratio of their perimeters is the same as the ratio of the lengths of their corresponding sides. So that's bullet point 3. If two polygons are similar, the ratio of its perimeters is the same as the ratio of the lengths of their sides. That gives us 2 blanks in that one, and let's keep going. It says in activity 11.3 on page 676, you may have discovered that the ratio of the areas of 2 similar polygons is not this same ratio. So after the semicolon, but the ratio of the areas of 2 similar polygons is not the same. So ratio of perimeters equal to the ratio of sides, but the ratio of the areas is not the same. Okay.
what section do you see that was gonna be on the ACT? You went over it and you're like, this is gonna be on the ACT.
I mean, there's geometry usually makes up about a quarter of the test. So there's usually out of 60 problems, there's about 15 that's related to geometry. So it's not like just one. I mean, there are
I
multiple.
know, but we were going through it, you're like, this is maybe like one of the big things on ACT.
I mean, I can't remember right off the top of my head exactly what would have been. I've said most recently, because I know I've said that about several things. So we'll go back over it. I mean, I'll talk to y'all about the things that we definitely need to remember. At the end of the year, I will give you a list that says geometry that you need to remember. Okay. But also, like Clara Jane said, she was doing her Algebra 2 homework along with her geometry homework, and she said right now in Algebra 2 they're dealing with circles. So what we've done in Algebra 1 and Geometry and Algebra 1, but what we're doing right now in Geometry with our circle formulas and stuff like that, she's using in Algebra 2. So again, it's the kind of thing where all of this stuff you're going to build on. Algebra 2 with trig, what is trig the study of? Triangles. So again, we've learned about triangle relationships. We've done kind of the basics with triangles. You're going to take it up a step further in Algebra 2, okay? All right, so Theorem 11.5 on page 677, Theorem 11.5, areas of similar polygons. If 2 polygons are similar with their lengths of corresponding sides and the ratio of A to B, then the ratio of their areas is A squared to B squared. Okay, so we said that we can have side to side, perimeter to perimeter, but now for area, it's going to be A squared to B squared. Okay, so we can see in the picture, in the box, we can see we have figure KA and KB. I can see we've got them labeled quadrilateral 1, quadrilateral 2. And I can see where the side length of 1 over the side length of 2 is equal to A to B, which is the perimeter. But now the area of quadrilateral 1 to area of quadrilateral 2 is going to be a squared over b squared. Okay, so sides squared. The a and b is sides squared. So let's look at example 1, finding ratios of similar polygons. Pentagons ABCDE and LMNPQ are similar. Find the ratio, red to blue. So we're going, so red will become first, then blue, of the perimeters of the polygons. Okay. So look at letter A. We're trying to find the ratio of red to blue. So remember we said that the perimeter of the polygon ratio is going to be equal to the ratio of the sides. What are the ratio of my sides in my two figures?
5 to 10.
5 to 10. So what does that mean? My ratio is 1/2. Okay, so it's 1 to 2. So now we have found the ratio of the perimeters. We can either leave it as 1/2 or we can write it as 1 to 2. Okay, so this is the ratio of the perimeters. We took the two sides, set it up as a ratio, simplified our fraction. Okay. So it says the ratio of the perimeters is 1 to 2. So the perimeter of each polygon, ABCDE, is half the perimeter of pentagon LMNPQ. Now letter B says find the ratio, red to blue, of the areas of the pentagons. So remember we said the area of 1 over the area of 2 is equal to side squared over side squared, right? I'm sorry, so I needed to, I guess it would still. So even if, so what is, we can either work with our reduced or our original, but I'll go ahead and show you what it's going to look like if you just use your original. So 5 squared is what? 25. What is 10 squared? What would that reduce to in simplest form? 1/4. So that's going to be 1 to 4. So we can see perimeter over perimeter. So perimeter of 1, perimeter of 2, side of 1, side of 2. We're able to find that ratio. I can either plug in my sides again, or I could have used my reduced fraction of 1 to 2, and 1 squared is 1 and 2 squared is 4. You're going to end up with the same thing, whether you used your reduced form first or you just stuck with your sides. Okay. So letter B says using theorem 11.5, the ratio of the areas is 1 squared to 2 squared or 1 to 4. So the area of the pentagon ABCDE is 1/4 the area of the pentagon LMNPQ. All right, so using our ratios again, setting up our proportions. Go ahead and look at example 2. It says using areas of similar figures, comparing costs. You're buying photographic paper to print a photo in different sizes. An 8 by 10 inch sheet of the paper costs 42 cents. What is it a reasonable cost for a 16 by 20 inch sheet? So it says because the ratio of the lengths of the sides of the two rectangular pieces of paper is 1 to 2. Again, the ratio of the areas is going to be 1 to 4, just like the example we just looked at. We said if we were looking at one of my pieces, 8 by 10, that would reduce to what? An 8 by 10, if I have 8 over 10 as a fraction.
4 over 5.
Okay.
Well, why wouldn't it just be 84 cents? Because everything's double. It's just
And so, but that's just the perimeter. Okay, but your area is going to be 1 squared to 2 squared. It says because the cost of the paper should be a function of its area, the larger piece of paper should cost about 4 times as much. So remember we said it was 1/4 of it. And so it should cost 4 times as much. All right, let's look at example 3, octagonal floors, finding perimeters and areas of similar polygons. So it says a trading pit at the Chicago Board of Trade is in the shape of a series of rectangular octagons. Yeah, that doesn't work. Is in a series of regular octagons. One octagon has a side length of about 14.25 feet and an area of about 980.4 square feet. Find the area of the smaller octagon that has a perimeter of about 76 feet. Okay, so let's set this up. All right, so they have told me one octagon has a side length of 14.25 feet. So we'll put octagon 1. We've got area and perimeter, not perimeter, we just have a side length. So it says the side is 14.25 feet. The area is about 980.4 feet squared. Find the area of a smaller octagon that has a perimeter of about 76 feet. Octagon 2, so this is, we'll put larger. This is my smaller. And they told me about it, that I have a perimeter of 76 feet. Now, what two things did we say we can set up as equal to each other? We said that the perimeter of 1 over the perimeter of 2 is equal to side of 1 over side of 2, right? We've said that those are equal to each other. And then we said the area of 1 over the area of 2 is equal to side 1, I'll make these down here, side 1, side 2. So side 1 squared over side 2 squared. Does that make sense the way I've made a note of it? So I've said I know that the perimeter of my first figure over the perimeter of the second is equal to the side of the first to the side of the second. So that's where we're going to start, okay? So if I'm looking at the perimeter of my larger octagon, how can I find that perimeter? What do I know each side is? 14.25. So to find the perimeter, how many sides does it have? It has 8 sides, so I'm going to multiply by 14.25. Okay, so what is 14.25 times 8? 114. Okay, so I'm going to go ahead and plug this in as my perimeter of 1, 114 feet. Now, what did it tell me the perimeter of my second one was? 76 feet. So they told me that in my information about my problem, okay, is equal to, what is the side measure of side 1? What do we say one side was equal to? 14.25. And what do we say, what's the side measure of this one going to be? How can I figure out the side measure of this one? Divide by 8. What is 76 divided by 8? 9.5 feet. Okay, so when I set this up, what should these do? They should be equal to each other, right? Okay, so what is 76 times 114.25? Say that again.
1,083.
1,083. What is 9.5 times 114? Huh? 1,083. So remember, I want to make sure, are these really equal to each other? The way that we know that is when I cross multiply and I get 1083. When I cross multiply this way, it's also 1083. So I know these two are equal to each other. Okay? Everybody good with that?
Mhm.
Now I'm trying to find the area of 1 over the area of 2. How can I find the area of my octagon here?
You put in your side 1 over your side 2.
Okay, so we're going to have side 1 over side 2.
We do know our area of the first one.
We do. So what is the area of the first one?
980.4.
Okay, we know the area of that one is 980.4. And I'm trying to find the area of the second. So I'll just put over A is equal to, what was my side 1?
9.
No, 14.25.
So I've got 14.25, and what do I have to do to that? Square it. And then what's my side of my other one? 9.5 squared. We'll stop there and come back after the break.
I'm Is everything on that week? Jared could not draw out. Draw out of class,
I'm so tired. I can't believe how it's tomorrow. It's freaking.
You can tell I was up late. I did some of my eyebrows. I was doing my face makeup. It didn't really work because my lighting was terrible. Also, face
We're
hair.
trying to get somebody to do my makeup because I'm terrible with makeup and my face look is like completely broken out. So that's fine.
My friend said thank you about her regulars. She loves her regulars.
I love regulars. They're my favorite jeans ever. They're so comfortable. I want to get more barn jeans because all of my Wrangler barn jeans are ripped in the butt. So I need new ones. I mean, I've had them for like 4 or 5 years. So
She spends her money, but like she
Yeah.
spends it wisely.
yeah, I want to do that, but I accidentally, or I brought my brother to help me with my geometry homework yesterday. I paid him $60 to help me. Something.
She works at Crappy Girl. She works.
Oh, cool. How fun. I work at a little barn in Monagano. I've known the lady since I was 10 years old.
I know she. I don't think she works. I mean, she goes there and that's what. Not that one. But I don't even know which one she goes up to. But I know she. Does. I get
Miss Jennifer,
Yes.
do you have the notes for 11.2? Because I forgot to write those down. I was trying to find them in my book.
Yeah.
I forgot to fill in this section here.
Good morning.
Let's see.
Sometimes I'll have them.
Okay, so 11, 2, you can see what we started with the area of the equilateral triangle. We previously learned that a polygon that has all vertices on a circle is an inscribed polygon. The center of the polygon and radius of the polygon are the center and radius of its circumscribed circle. The distance from the center to any side of the polygon is called the apothem. A-P-O-T-H-E-M. And it says the apothem is the height of a triangle between the center and 2 consecutive, I think it's vertices, let me make sure. Between the center and 2 consecutive vertices of the polygon.
How do you spell it?
B-E-R-T-I-C-E-S.
Okay. What is the difference between a apothem and a radius?
Okay,
I was confused.
So let's see, look on page 670. Okay, so see, my radius would go from my center all the way to a vertex that touches the circle. Okay, so my radius goes from the center to the circle. The apothem only goes from the center to the edge of my polygon.
Is it always going to be the middle of the side?
Yes.
Okay.
Yes, so it's always because remember this is gonna be my altitude, okay? And so remember it cuts these 2 in half, so I know these 2 sides are gonna be congruent.
Yeah.
And I know it intersects at a 90-degree angle, okay? So that's why I can use Pythagorean theorem, because if I know that I know this side length, then I can divide by 2
Yeah.
and find just this one. If I know my radius, then I know these 2 and I can solve for this side. Or if I know the apothem and I know a hypotenuse, I can find a side, or, you know, if I have the apothem and a side, I can find the hypotenuse, which is gonna be the radius. So that's how they all kind of tie together. Okay, so the radius is always gonna be longer than the apothem.
Okay.
The radius goes from center to the edge of the circle,
Okay.
whereas the hypotenuse stops at the edge or a side of my figure.
Okay.
Then let's see, we've got theorem 11.4, area of a regular polygon. And so we have that on there. And then the last bullet point says a central angle of a regular polygon is an angle whose vertex is the center and whose sides contain two consecutive vertices on a polygon. You can divide 360 by the number of sides. To find the measure of each central angle of the polygon.
Thank you.
You're welcome.
So I got this strapless dress for prom, and I'm so nervous that it's gonna fall down.
I know.
It's got straps that attach to it, so I can use them if I want to, but I've never like actually worn a strapless dress that much, so I'm like, I don't know. I'm so nervous.
If I see I fall out like Auburn.
Oh my
In my
God.
big dress.
Now, one of the
and fall
things
on
I
my face.
recently discovered, because that's what my daughter, the dress that she's
Yeah.
getting, like the sides of it,
Yeah.
like it laces up in the back, so the sides of it, but they said
Yeah, there's
the
a
sticky
zipper in
tape.
that. Okay.
But you could always get like, I think you could get sticky tape
Okay.
and put it on the inside of the dress, and then you could stick it to where it would hold it up.
Yeah.
Now, I've never used it or never tried out, but evidently there's sticky tape that you can
I
use.
feel like that.
Yeah, and so you can use that.
Yeah. I'm gonna be like, over there with the duct tape.
Yeah, making sure it doesn't fall.
I'm thinking about wearing these boots, but
I
the dress
almost
is
saw
so
that big.
long.
Yeah.
Yeah, and these are
It's gonna go-
shoes.
I do not want to wear shoes. I hate heels.
I'm bringing my, wearing my heels and I'm bringing
She
my
drove
pants.
to He drove 5 hours just to go.
Alrighty. So we stopped here where we said, we know that the perimeter of 1 over the perimeter of 2 is equal to side of 1 over side of 2. We said that those ratios are going to be the same. Okay, so we proved that. I wanted y'all just to be able to see it's not just, it actually works. So, and then we also learned that the area of 1 over the area of 2 is equal to my side of 1 squared over the side of 2 squared. We knew the area of my first one. We're trying to solve for the area of the second one. So we set it up to where we have the side of 1 squared over the side of 2 squared. So what is 14.25 squared?
It's gonna be a big one.
It is gonna be a big boy number.
It is 203.0625.
Big boy.
Okay, say that again.
203.
So this is 14.2 square, 14.25 squared equals, so I have 980.4 over A is equal to, say that again,
203.0625.
0.625. We'll go ahead and leave it as that. Over 9.5 squared.
90.25.
90.25. So now what am I gonna do? What am I gonna need to do here?
Cross multiply.
Okay, so I'm gonna cross multiply. So, let me look at something real quick.
Just imagine.
You sound like my brother. My brother's got this old sewing machine upstairs, and he's always like banging on it.
What?
And he's just like tapping on it all day. And
Everybody
it's just
say he
squeaking.
always sews
So
that
it'll
much.
start squeaking, and I'm like, bro, you gotta stop. Because I can hear it all
That's
over
what
downstairs.
shoelaces in bed.
Okay, so when we cross multiply, we find that we've got 203.0625 times A is equal to 980.4 times 90.25. Let me go ahead and just multiply those.
Oh.
And then I'm gonna ask you guys in a minute, so I want you to be looking and see how could this have been done easier?
I really know how it can go now.
8,848 and 1.1.
Oh, I think
Okay,
that's
well, let's
what we're
do it.
doing here. There's something.
This is an operator.
My brain always hurts. It's okay.
Just imagine, my friend,
No, that's not his grade, that's A.
she was like a white kid. He's rapping with his, like, he was rhyming.
Okay, so if you're talking, that means you figured out the easier way to do it. So tell me what would it be?
It would just do these.
Go ahead and get a smaller ratio at the beginning.
Get a smaller ratio at the beginning, and where would I get that smaller ratio? Where would that come from? I could either use the two perimeters or I could use my two sides and I could have a smaller ratio. That means I would have to be able to cancel here the 114 over 76. What would that reduce to?
1/3.
Huh?
3 over, like,
3 over what?
2.
3 over 2. So that means that here, I could have used smaller numbers, but what I want you to see is even if you don't remember to reduce, it's still going to work out. Because when I set it up, even when I did 14.25 squared and I got 203.0625, and then when I did 9.5 squared and I got 90.25, when I cross multiply and I have 203.0625 times A is equal to 980.4 times 90.25, and I got, what was that, 88,481.1? Even when I do that and I divide this side by 203.0265, when I solve for A here, remember those cancel out. So I divide this number by this number, I'm still going to get the same answer. Okay. Now, obviously, this would be calculator work. Yes.
In the book, it did 76 and 114 or something.
What did we learn when we started talking about proportions? Remember, in this situation where I have perimeter of 1 over perimeter of 2, the main thing is that my numerator, my top information corresponds with the top information of this one. So it doesn't matter which one's the numerator, which one's the denominator, because when I cross multiply, I'm setting them equal to each other either way. So that's why I'm trying to show you different ways as we go through the practice. Then you've got the example in the book also. So the proportion does not matter. What does matter setting up a proportion is that you've got corresponding information in the numerators, corresponding information in the denominators. They set it up differently where they had smaller than larger. We set it up where we had larger than smaller. Okay, but either way, you're going to come out with the same thing. Here, we could have reduced with when we set up our proportions here, 114 over 76 reduces to 3/2. 14.25 over 9.5 reduces to 3/2. Or I could have flipped it and had 76 over 114 and 9.5 over 14.25. Then it would have been 2 over 3. But again, either way, however I set it up, you just have to have your corresponding information in the numerators, corresponding in the denominators, but you're still going to get the same answer.
So could you work out the 3 of 2?
Okay, so if you wanted to look at it that way, then I'm going to have the 980.4 over A is equal to 3 over 2. So I've got 3A is equal to, what's 980.2? 0.4 times 2?
1,960.8.
1960.8.
Yes.
Divide by 3, divide by 3. Divide that 1960.8 by 3.
653.6.
Hold up. Oh, I didn't square them. My bad. That's what, this was supposed to be 3 squared over 2 squared. Let me fix that real quick. So 3 squared is 9. So we've got 9A is equal to, what's 2 squared? It's 4. So what's 4 times 980.4? 3,921.6. So now divide by 9. Divide by 9. What is 3921.6 divided by 9?
435.7. We repeat.
So we ended up with the same answer. Okay, the other way is just taking it as it is instead of reducing. We can see that by reducing, I just end up with smaller numbers. I'm still working through it with the calculator, okay? So that's why I want you to have confidence in knowing that it's not magic on it's got to be one set of numbers, one set of ways. The concept is that when you set up your proportions, is that it's corresponding information. Okay, that's the main thing you've got to make sure, is that when I put information in numerator 1, that I'm putting the same, that I'm putting corresponding information in numerator 2. Okay, so I couldn't flip flop it and have the perimeter of 1 here and the side of 2 here. Okay, I couldn't have something about figure 1 here and figure 2 here. It has to be figure 1, figure 1, figure 2, figure 2. Okay, but again, it doesn't matter which one's in the top and which one's in the bottom, as long as they're in the same location each time. All right, so that's 678. So that puts us at guided practice for this section. Pretty quick, huh? Okay, so it says if two polygons are similar with their lengths of corresponding sides and their ratio A to B, then what is the ratio of their perimeters? So what do we say? How do the side ratios compare to the perimeter ratios? What did we learn here when we looked at sides and perimeters? They were the same, right? So if my perimeter ratio is A to B, I'm sorry, my sides are A to B, then what is the perimeter going to be? A to B, it's going to be the same. Yeah. If they said the ratio of one is A to B, then the ratio of the other is A to B. What is the ratio of the area is going to be? A squared over B squared. Good. Okay. The second section says, tell whether the statement is true or false and explain why. Number 2, any two regular polygons with the same number of sides are similar. Why?
Because a regular polygon has congruent sides. So I mean, if they have the same sides, they're similar.
Okay, they're going to have, my side ratios are the same, and what else is going to be the same about each of them? The angle measures. Good. So the angle measures are going to be congruent, but my sides will be proportional.
So is this one true?
So number 2 is true. All right, number 3, doubling the side length of a square doubles the area. Doubling the side length of a square doubles the area. So let's think about this. If I've got a square that is 3, okay, what is double my side length?
6.
Nope, remember that'll be 3 times 2. Double means times 2. So to double it would be 3 times 2, which equals 6. Okay. And then it says doubling the side length of a square doubles the area. So that means if I would have a 6 there, okay, what's the area of this one? The area of this one will be 3 times 3, which is 9. What's the area of this one? So notice that my area is actually 4 times that. So remember we said the ratio was 1 to 4. So just by doubling my side measures, going from 3 to 6, and this one, my area is 3 times 3, which is 9. 6 times 6 is 36. So I can't just double them and expect the area to double. It actually increases 4 times. All right, so number 4, it says in exercises 4 and 5, the red and blue figures are similar. Find the ratio from red to blue of their perimeters and of their areas. So in this particular problem, remember I said that it doesn't matter which way you set it up. If your directions tell you how to set it up, then that's what you need to do. And this one, it says compare red to blue. So my number for red will be first, then my number for blue. Okay, so what does it tell me my measure is for my red figure in number 4?
3.
So 3 over, what is the measure of the blue?
9.
9. So what does that reduce to?
1/3.
1 over 3, which equals 1 to 3. Okay, so there's our ratio right there. Now, how can I find the ratio of their areas? So this is the ratio of perimeters.
Using Pythagorean theorem, right?
Pythagorean theorem has to do with sides of a right triangle. Are we talking about sides of a right triangle here?
No.
What did we say? The ratio of the perimeter. Remember we said ratio of perimeter is A over B. What do we say the ratio of area is? A squared over B squared. So basically, this is the ratio of my perimeter. This is A to B. So what is the ratio of the area going to be? 1 over, well, let's do 1 squared over 3 squared, which is 1 over 9, which I would write as 1 to 9.
Can't you, wouldn't you find the, oh wait, never mind.
Okay, I'm not having to find the area of anything. They're saying find the ratio of the areas. Okay, so I'm not having to find the area. They just said find the ratio of the areas. And in this section, we talked about how the ratio of the perimeters is equal to the ratio of the sides, but the ratio of the areas is going to be sides squared, okay, or that ratio squared.
So in these problems, could we find the perimeter by find the number of sides by the perimeter?
I don't think any of the questions are going to ask you to do that. It never says find the perimeter. Okay, it's saying find the ratio. And I can do that by comparing the two sides. So putting side over side gives me the ratio of the sides, and we know that's equal to the perimeters, equal to the ratio of the perimeters. All right, look at number 5. All right, what is the ratio of my sides here? I'm sorry? Okay, so remember they said go from red to blue. So what is my red number?
6.
Blue is 4. So what does that reduce to?
3 over 2.
3 over 2, which is going to be written as 3 to 2. Okay, so that's the ratio of the perimeter. Now I need to do the ratio of the area.
5.
So I'm going to have 3 over 2. And what am I going to do to those? Area means I've got to square them. What is 3 squared? So 9 to 4. Because it says find the ratio of the areas. It doesn't say find the area.
Why they give the height throws off?
Because what they're trying to see is, do you know how to find the information you need? Okay. You've got to be able to look and say, hey, this is what my question is asking me. I've got to be able to look at my figure and figure out what information do I need to solve this problem. I don't need the height of the figure to solve it, okay? A lot of times, anytime you're given the height, especially of a parallelogram, I'm given the measurements of a parallelogram, a lot of times they're going to give you the height unless they're wanting you to solve for the height. And in that situation, you're thinking about Pythagorean theorem because you've got a right triangle there, okay, if you're having to try to find the height. But in this situation, that's not what they're asking us to do. So let's look at our homework for this section, 11.4, 11.3, my bad. 679 to 680, we've got 7 through 15 all. Notice this is different, 7 through 15 all. So page 679. 7 through 10, we're doing just like we did in numbers 4 and 5. We're setting up our ratios, and it says to find the ratio of the perimeters and the areas, okay? 11 through 15, or 11 through 13 is going to be an always, sometimes, never. 14 and 15, they've given me similar figures, and I've got to find the scale factors. And for number 14, the ratio of the area, okay? So in that, I'm remembering, hey, A squared over B squared. Turn over to page 680. You're going to do number 16, right triangle. Now look at this. Triangle ABC is a right triangle whose hypotenuse AC is 8 inches long. Given that the area of triangle ABC is 13.9 square inches, find the area of a similar triangle DEF with a hypotenuse of 20 inches long. Okay, so you're going to need to set everything up, and then you are finding the area of another figure. Look at numbers 19 through 21 all. 19 through 21. So 19, 20, 21. Again, each of these are dealing with scale factor. Okay, so your answers are going to be given as ratios. Okay, now I will tell you in these, they may involve some square roots that you can either express as a decimal or you can express them as a simplified radical. Okay. All righty, 11.4, yay. Circumference and arc length. Let's see how much time we've got. Okay, page 683, circumference and arc length. And it says goal 1, finding circumference and arc length. It says the circumference of a circle is the distance around the circle. What was my distance around a figure that we talked about in the previous sections? Perimeter. So perimeter and circumference are similar, and that I'm talking about the distance around the figure. But why is it different with a circle? What does a circle not have? Sides. Okay, so that's why I'm dealing with a circle is different. So it says the circumference of a circle is the distance around the circle. That's bullet point 1. And it says for all circles, the ratio of the circumference to the diameter is the same. The ratio of the circumference to the diameter is always the same and is known as, you can write the symbol pi or pi pi. So this is our first paragraph under goal 1, page 683. Okay, so the circumference of a circle is the distance around the circle. For all circles, the ratio of the circumference to the diameter is always the same and is known as pi or pi. Okay. So theorem 11.6 tells us this: the circumference of a circle is C equals pi d, or C equals 2 pi r, where d is the diameter of the circle and r is the radius of the circle. So the third bullet point, where d is the diameter of the circle and r is the radius of the circle. So remember, my diameter is 2 times the radius, or the radius is half the diameter. Okay, diameter big, radius half of it. Okay. So in example 1, using circumference, it says find A, the circumference of a circle with a radius of 6 centimeters, and B, the radius of a circle with a circumference of 31 meters. Round the decimal answer to 2 places. So in example 1, I'm using my formula, circumference equals 2 pi r. Okay, what does it say the radius of my first one is?
6.
Okay, so I have C is equal to 2 times pi times 6. What is 6 times 2? 12, so that means 12 times pi. Using your calculator, what number are we going to usually use for pi? 3.14. So you're going to have 12 times 3.14, and you're going to find your circumference is approximately
37.68. So round that to 37.7.
Okay, good. Why are you rounding to 37.70?
Because the number next to 6 is higher than.
Why am I not just writing 37.7? Are these the same?
No.
If you're paying money and your total is $37.70, is this the same as $37.70? No, there's a 0 after it.
Oh, no, I mean the second one, right? Oh, okay.
It doesn't matter about zeros. Why am I putting a 0 in this answer?
I think for 6x.
What do my directions tell me? 2 decimal places. We've got to pay attention to what the directions are asking me. Okay, the directions say 2 decimal places. One of the things I strongly encourage you to do is obviously read the directions, work the problem, go back to the question, go back to the directions and say, did I do it according to the directions? I had the same discussion with my son because he had some science video project where he had to like video something and edit and blah, blah, blah. And so of course we were last minute doing it and whatever. And he didn't do his video one day, so he had to wait for the next day. And of course then the project's due the next day or whatever. So then yesterday I picked him up and I said, hey, how'd your project go? Yeah, I found out I did it totally wrong. I said, well, what do you mean you did it totally wrong? He said, well, the directions she gave out said whatever. And I said, that's interesting. When did the directions come out? Oh, a couple of weeks ago. I said, oh, so you've had the directions a couple of weeks ago and you did it the day before it was due and you did it wrong? There's a shocker. And so I said, you've got to plan, read the directions. Anytime you're doing a problem, a project, read the directions, know what the guidelines are, set up your plan to do it. So that's what we do in math. We set up our plan by setting up our problem, using everything that we know, plug in what we know, we're solving for what we don't know. And then I go back and look at my directions and say, did I do it like I was supposed to? Did I follow the directions? Okay. So that's going to be super helpful going forward, is making sure. Because if your directions on a test specifically say one thing, I usually try to be kind of lenient when you're rounding decimals. Okay. Sometimes, sometimes people leave it to 4 digits. Sometimes people go 1 digit after. I'm real lenient about that unless the directions say specifically this is what you need to round to. In that situation, I am going to count off because you've got to follow the directions. Okay, so that's why we left it at 37.70. It does not matter if I do have a 0 here. If I don't have a 0, it does not change the value of the number, but for my answer purposes, it has to be there. Let's look at letter B. What does it say the radius of this circle is?
31 meters.
The radius is 31 meters. So I'm going to have C is equal to 2 times pi times 31. What is 2 times 31? What information do we have in this problem?
The circumference is 30.
We have the circumference. So look at what we've done up here. What was the mistake?
See,
It's not the radius that's 31. It's the circumference. Okay, so again, in this problem, they've given us their circumference is 31 meters. So I'm going to have 31 is equal to 2 times pi times r. Okay, what am I going to need to do to solve this problem?
Plug in pi.
Okay, and so if I plug in pi and I've got 31 equals 2 times 3.14 times r. Now what do I need to do?
Multiply 2 times pi.
Okay, so I've got 31 is equal to, what is 2 times 3.14? 6.28 r. Now what?
Move the 6.28 to the other side.
How am I going to move it to the other side?
Divide.
I'm going to divide it because this is multiplication. To undo multiplication, use division. 6.28, 6.28. What is 31 divided by 6.28?
4.9363.
Okay, 4.9363. So what do I need to round to?
4.90. No, 4.9.
So if we did 2 times 3.14 is 6.28. So we've got 31 divided by 6.28, 4.936. So in the book, they did not round up the 4.93. It should actually be rounded to 4.94. And that would be my radius. They just took the first 3 and did not round. So really it should have rounded to 4.94. Okay, so again, circumference formula. This is something that we used in pre-algebra. Okay, so this is something you've seen before. So again, we're starting with the foundation, we're starting with the basics, and we're going to build on that. So the arc length is a portion of the circumference of a circle. So remember when we talked about arcs and we talked about how we could find the measure of an arc based on the measure of the central angle? This was last chapter, last test, where we said that if I've got a circle and I've got my center and I had a central angle right here, and I said this angle was 85 degrees. Now, who knows what it actually is? But if I said this is 85, then what is this going to be? 85. Okay, so remember, if it's a central angle, my central angle is the same as the arc length.
I thought it was 1/2.
That is if it's on the circle. If this was 25, then this one is 50. So it depends on where my angle is. If it's on the circle, then it's going to be 2 times that.
On the test yesterday, I was.
If it's in the center, it's exactly the same. So it depends on where your point is. Okay, so it says an arc length is a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. So bullet point number 1, 2, 3, 4. An arc length is a portion of the circumference of a circle. And you can use the measure of the arc in degrees to find its length. And then it has in linear units.
Look at 682. I found like 5 trillion.
So we've got the arc length corollary at the bottom of 683. And it says in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measures of the arc to 360 degrees. So let's fill in that bullet point. In a circle, the ratio of the length to the, let's see, the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So arc length corollary in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So we can see this in the setup of the equation. The arc of the length AB over circumference 2 pi r is equal to the measure of arc AB over 360. Another way to look at it is we could have the arc AB is equal to the measure of AB over 360 times 2 pi r. Okay. Go ahead and turn over to page 684. And at the top it says the length of a semicircle is 1/2 the circumference, and the length of a 90-degree arc is 1/4 of the circumference. So that's the last bullet point. The length of a semicircle is 1/2. So you can just put the fraction 1/2 the circumference, and the length of a 90-degree arc is 1/4, which is 1/4 of the circumference. Okay, so let's look at example 2, finding arc lengths. Find the length of each arc. Okay, so letter A. What information do I have here?
Example 2.
Letter A, example 2. What information have they given me?
That the areas 5 centimeters.
No. What is 5 centimeters?
That arc, I think.
Mhm.
No.
What is the distance from the center of a circle to the edge of the circle?
Oh.
A radius. So we know our radius is equal to 5 centimeters. Okay. What do I know that my arc measure is?
50.
I know my arc measure is 50 degrees. Is it AB? Yeah. Okay, so what is my formula that I'm using?
50. Oh, wait.
If you look back at 683, I can see that the arc length, so I'm using arc length over 2 pi r is equal to the measure of AB over 360 degrees. Okay. They also said that I can look at it as the measure of AB over 360 is equal to wait a minute.
Measure of baby is 50. Can we place that in there?
Hold on just a minute. Times 2 pi r. Okay. So I'm going to use this formula here because I know the measure of AB, right? And I know radius. So I'm going to plug this in. My measure of AB, we said, was 50 degrees over 360 degrees times 2 times pi times 5. Because they told us these two things. Okay? So how do we want to attack this? What do we want to do first? What does order of operations tell me I do? What is this called? Division. What is this? Multiplication, 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 right? Because we've, in essence, when we clean this up, we've got 50 degrees over 360 degrees times 2 times 3.14 times 5, right? What does order of operations tell me to do?
Multiplication and then division.
Is that what it tells me?
No, it's in whatever is first in the order.
When you do PEMDAS, if you have both multiplication and division, the same problem,
You do which order?
in order from left to right. Same thing with addition and subtraction. If there's both addition and subtraction in the same problem, you do it in order from left to right. And let's look at that. What is 50 divided by 360?
0.138.
Okay, so we'll go ahead and make that a 9 at the end. 0.1389 times 2 times 3.14 times 5. Okay, so what is 0.1389? 0.1389 times 2 times 3.14 times 5.
4.36146.
That's not what I got.
And let's look at, okay, so try it again, Claire Jane.
I
Point.
got 4.31 repeating.
Okay, so let's look at it. Do 0.1389.
Oh, I think I just used the unrounded version.
Okay,
0.1389
times 2 times 3.14 times 5.
4.3614.
Good, so approximately 4.36. Now also, one of the things is, we could have multiplied these together, but we still would have had to have divided this before we could have multiplied these two together. Okay, because this is just 50 divided by 360. I'm not dividing the whole thing by 360. Okay, so just remember multiplication and division in order from left to right. Let's look at B. What information do I know?
All right, we have a radius of 7 centimeters.
Radius is 7 centimeters. What do I know the measure of my arc is?
C is equal to 50 degrees.
50 degrees. So I'm going to set it up where I have my arc, which is 50 over 360 is equal to 2 times pi times 7. Oops, that has to be times. So again, when we divided those, we already have 0.1389 times 2 times 3.14 times 7. Point 1389 times 2 times 3.14 times 7 is approximately 6.106, so we'll go 6.11 centimeters. Now let's look at letter C. What do I have in C? What is my radius?
Radius is equal to 7 centimeters.
7 centimeters, and what is
EF is equal to
100 or
100 degrees. So I'm going to have 100 degrees over 360 degrees times 2 times pi times 7. What is 100 divided by 360?
36.
Mm-mm.
3.6.
360 will not go into 100 three times. Point, huh?
0.27.
Mm-mm. 100 divided by 360.
That's what I typed in.
Is that what you got?
Yeah,
I thought it was 360.
it's 0.27 repeating.
If it was 360 divided by 100, it would be 3.6, right?
So we've got 2.2777. So let's go 0.28 times 2 times 3.14 times 7. So 0.28 times 2 times 3.14 times 7 is approximately,
12.30.
so it's 12.308.
So 12.31.
Okay, so they must have used, we rounded that 0.28. Let's see if they use different. So they did 100 divided by 360 equals, let's see if it times 2 times 3.14 times 7.
What did they do?
Yeah, so what they did, instead of rounding, when they did the calculation, they just did the 100 by 360 and left it the extended number, whereas we rounded to 0.28. So the book has 0.21, but if you would have rounded just to 2 digits in the beginning, then it's going to have what do we say, 0.2?
Yeah, it's 12.22.
Okay. All right, we will stop there.
Okay.
Okay, so when we return on Wednesday, we'll pick up with example 3. So that means for homework, next Wednesday, you need to have homework for 11-1, 11-2, and 11-3 done. 11-1, 11-2, 11-3. We're going to pick up on 11-4 on page 684, example 3.
11, 1, 2, 3, and 4.
No, only 11-1, 2, and 3. Okay, those are the ones that we've completed. We've completed sections 11-1, 11-2, 11-3, so that'll be the homework. We'll pick up with example 3. So next Wednesday, we'll finish 11-4. We'll go on to 11-5, and we'll see about 11-6. Probably not by the time we do homework. We should finish chapter 11 by the end of next week. So that means 12 will be the final 2 weeks. Okay. Be sure to let me know if you need help or have any questions. And I hope everybody has a great weekend. Bye, guys.
Next Wednesday, because I, 2 weeks